So I know the video quality is really bad, but we're not here for the video quality. We're here for me to practice if I learned anything. So I'm just gonna jump into cellular responses and cell injury and see how much I can teach you, I guess. So first we're gonna talk about whether it's a pathologic or a physiological process. So if it's physiological, it's something that's normally going to happen within your body. And if it's pathological, that usually means there's something external that's impacting you that's bad. Usually physiological, it's supposed to happen, and it's adapting in different ways. So some of the cellular responses would be atrophy, which I think is a bit more common, like everyone kind of knows it, but it's when your muscles usually just shrivel up. But it's not necessarily muscles, it's just cells getting smaller or decreasing in number, both. And nope, just kidding, I take that back. It's your cells are getting smaller. And so usually atrophy physiologically could happen if you don't use a muscle for a long time, it'll atrophy. So if you have like a cast on and you can't use your muscle and then you take it off and your arm's kind of shriveled or whatever, it's because your muscle had atrophied. And there's a few other examples of that happening, not just like a cast. The next cellular response would be, or I guess I should say, a pathologic response example of atrophy would be probably like a chemical inhibitor, like, or no, if you're nerve, no, because that's still, so I guess I'm having a hard time with the pathological, but for physiological, if your nerve running to a muscle or something gets impeded, or if the blood flow to the muscle gets impeded, that can cause it to atrophy as well. Hypertrophy is the cells get bigger. So that is a physiological example of that is like if you work out and then your muscle looks like bigger right after you do a few pumps of whatever, it's because the cells have swelled up in response to the stress put on them. So that's your hypertrophy. And bad examples of this would be anything to do with cells swelling when they shouldn't. So probably something with the heart. This is not a very comprehensive review. I'm just doing my best. Our next cellular response is hyperplasia, which means that's the increased number of cells. So hypertrophy is the cells are getting bigger, but the number stays the same, but hyperplasia is there's more cells present. Another example, going back to hypertrophy of the cells expanding, you can have a physiological response of that is an example of like puberty for girls, like having the breast tissue expands, and then the same for when you're pregnant and lactating, the tissue expands, but the number of cells stay the same, they just get bigger because they're in like a functional component. And so hyperplasia is an increased number of cells. I can't think of any examples off the top of my head, so we're just gonna keep going. And hypoplasia, decreased number of cells. Same kind of thing, I can't think of an example. There's also aplasia and metaplasia listed. I do know metaplasia. I'm gonna come back to aplasia because I don't remember it. I could be mispronouncing it as well. Metaplasia is when your cells change to another, they adapt for their environment. So like the common example that we had covered last block was Barrett's esophagus, which is when you swallow food and it goes down to your stomach, and if the stomach acid comes up at the bottom of the esophagus, your cells there will start changing from regular esophagus ones to closer to what your stomach lining looks like, because if you're getting like an acid reflux and it's coming up, your esophagus cells are not prepared for that much acid. So they're like, we want a little bit more of a mucosal kind of vibe going, like the stomach's lining, so that way the acid isn't eating through it. So that usually turns into metaplasia. So the cells have adapted to what their environment is. And then if metaplasia continues and it's not treated, like you say, I'm just gonna keep eating highly acidic foods and not tone it down, then the metaplasia can convert into dysplasia, which is like a more aggressive version, like less ordered. So your cells, they've changed how they are, and now they're trying to just keep up with it. I could be wrong in this as well, but I know the next step after metaplasia is dysplasia, and that can be indicative of cancer later down the line if that's not dealt with. And now it says the objective is to identify examples of everything. So I should go back to hyperplasia, hypoplasia, and aplasia, and then I'll get into that a little later. And causes and mechanisms of cell injury. Basically, if anything hits your cell and it gets to the outer membrane and breaks the outer membrane, cell injury. If the mitochondria is like, the cell's not doing so hot, I'm gonna abort mission, they send out cytochrome C, and cytochrome C says, okay, we are scheduled to die at whatever point, because cytochrome C will do apoptosis, which is like a planned death, versus necrosis, which is not planned, the cell just dies. So if the cell if anything happens to the membrane, the cell's just gonna abort mission. The mechanisms, I kind of went over it with cytochrome C. There's a few other factors that go into it as well. One of them is BAX. There's like BAX, BAC, and a third one. It starts with a B as well. And those will say, they're like pro-apoptosis. They're like, yes, kill the cell. And then there's a couple that are anti-apoptosis, and that's BL2 and BXL, something like that. And there's like, nope, keep the cell alive, like, we're fine, we can come back from this. So those are those. And anything that's ischemic or hypoxic means there's not enough oxygen to that area. So the cells don't make enough ATP, which is their energy fuel source. And they're like, oh, we don't have the energy. We can't keep up with this, the cell membrane. It has a charge along it that kind of balances where the ions are and everything's functioning as it should. So you take the batteries out of your cell, and all the calcium's coming in from like mitochondria, from the cytoplasm, not the cytoplasm, it's coming into the cytoplasm, and then outside the cell is coming into the cell. And the cell does not like that. So even if you don't have, like, if the oxygen's down, your ATP is down, your calcium is up, and then all of a sudden you get oxygen back, well, you still have all this junk everywhere. And so you can, it kind of runs the risk of I forget the word now, sorry, free radicals. So it's usually like hydrogen peroxide, hydroxyls, things like that, they're not good for your cells, and they're kind of toxic. So let me just go back to what I didn't know. So we cover everything. Oops. Aplasia is the completely lacking. So if an organ never develops, then that's aplasia. And the example they gave was thymic aplasia in DeGeorge syndrome. So you just never have a thymus. And I was missing 2 examples of the other things. So it's hyper and hypoplasia. So, I did it backwards. Okay, so hyperplasia is the one with the breast tissue, and that makes more sense than just larger cells. And then hypoplasia. So pathologic hyperplasia would be if your hormones are kind of out of whack and then you get excessive hormonal stimulation. But usually it'll regress and like go back to normal if you shut off the overflow of hormones. Hypoplasia is the incomplete development of an organ, so it doesn't reach adult size. And then they have an example of a streak ovary in Turner syndrome. And so now I have to go back to confirm things. Sorry. So atrophy is decreased workload, so that's like you're not working out your muscles. Aging process, you atrophy. Diminished blood supply, no nerves, not enough nutrition, or the end stage of an inflammatory process. So hypertrophy is the one that I wanted to correct then as well. So you have it happening a lot in non-dividing cells in response to stress. So like cardiac hypertrophy, because if you always have high blood pressure, your heart's working a lot more. And what we were saying was like the muscles, your heart's a muscle, so it'll the cells will get bigger and it'll make it harder for the flow to continue through it. So you don't want it to be persistent, because if it goes on forever, then organ failure could happen. Let's see. I've got photos of some of these, but you probably don't want to see them because they're explicit, so somewhat gory. Some of it's histology, which looks like your ink blot test, but I think that's everything for this. So I'll do my next video on my next little lecture that I'm going to. All right.